So the first thing we're going to talk about today with soil is regolith. Okay, this is a layer of weathered rock fragments that cover most of the Earth's surface. Okay, then there's what is known as bedrock, and this is solid unweathered rock that lies beneath the regolith. Okay, there are two types, solid and broken. Obviously, exactly what they say they are. If something's solid, it's whole, put together, and if something's broken, it's pieced up, okay? So soil is made of a mixture of weathered rock particles and organic material known as humus, okay? Humus is plant or animal material, and it is very dark in color. Most organic matter that is actually found in soil comes from plants, okay? And it makes sense because where do we find plants? In the what? In the soil, okay? So soil is mostly sand, clay, or silt particles, and that's what we're going to use the triangle for today, okay? But soil texture is actually determined by the particle size. So clay is the smallest particle size, so it is less than 0.002 millimeters. It's pretty small, okay? This comes from weathered rocks containing feldspar or aluminum. Silt is a more medium particle size, so just slightly bigger than clay and averaging up to 0.06 millimeters. We typically find this around riverbanks, riverbeds, or lake beds. And last is sand, and sand is actually the largest particle size and the one that we are probably most familiar with, okay? And this is just above your silt and ranges up to 2 millimeters. Okay, so this is weathered from rocks containing actual quartz. So keep these in mind, okay, when we're using our soil triangle. So this just gives you an idea of size. So up here you see a piece of gravel, okay, pretty large, something we can walk outside and pick up, see, right? Then you see sand, silt, looks just like a pen dot up there, and clay, which you can't even see on this scale. That's how small the particle size is. Okay, so this is just to give you an idea of the actual size of these various things. All right, so this is what we're going to learn how to use today. So this is an actual triangle, and how we determine when we're given different percentages what it actually is. So we're going to be looking at different percentages of clay, silt, and sand, and then we're going to be able to determine what it actually is with those compositions. Okay, so I'm going to give everybody one of these. Sometimes things like this are easier to have paper for. So I'm going to do a little bit of back and forth between some slides. So the first one that we're going to look at when we read our soil pyramid is 30% clay, 50% silt, and 20% sand. I'm going to get some fancy colors here. So we're doing 30% clay, 50% silt, 20% sand. I'm going to write the next one down just so we know we don't have to keep flipping. right, so the way that this works, if everybody looks at the one on the board and then you compare it to the one that's in front of you, okay, same. So over on this side, on the left side, we see percent clay. On the right side, we see percent silt. And at the bottom, we see percent sand. So when you are given the different percentages, where they all meet is going to give you what you're actually looking for. Okay, so let's do clay. So the first one says 30% clay. Okay, so we're over here. Everybody following? So we're going to find 30. Everybody with me? And you are going to make a line. Okay, we're 30% clay. Next, we are 50% silt. Okay, so we are going to go to the right hand side. We're going to find 50, right? And we are going to make a line. And then last, we're on 20% sand. So now we got to go to the bottom. We go to the bottom and we find 20. So 20 is all the way over here. So now we're going to come across and we are going to make another line, okay? And where these lines intersect, okay, that is where we are going to determine what we're actually looking for. So in this case, okay, they don't all technically intersect in one spot. We've got 30, 50, and 20, okay? So we're looking at where on the triangle. Where are these colors all at? Which one? The silty clay loam, okay? So that is what we would put. The next one we're gonna do is 20% clay, 40% silt, and 40% sand. So 20% clay, so we're gonna find our clay, and we're gonna go across. We're gonna find 40% silt. So now we're coming down. Those are terrible lines. And last, we are going to do 40% sand. So now we are going to come up. Okay, so this might look just a little bit different on your paper. So we've got our 3 lines. And where do they fall? In the what? Where? Loam. Right? Purple, green, pink. We're in the what box? We're in the loam box. Okay, so that would be the answer. Now on your paper, okay, they might all intersect exactly, because I know I printed one out and they all intersected exactly. So where the 3 lines touch or come together or look very similar to this, where they come is what your answer is. Does everybody follow me? I'm going to give you some practice today to make sure that we know how to do it, okay? But if you have questions as we go through, please make sure that you ask, okay? Hard? Easy? Pretty easy? Intersecting lines, that's it, we're drawn, okay? I recommend doing colors to see where they intersect so that it gives you a better idea, but you can work with a pencil. You can do different colors for different questions, okay? All right, so The next thing we're going to talk about is the actual soil profile, okay? So this is the cross section in which the layers, AKA horizons, so think the horizon. Which way does the horizon go? Vertical or horizontal? Horizontal, okay? So this is of the layers of the soil and the bedrock can be seen. And we're going to go through these different pieces. So there are 3 horizons, okay? A, B, and C. So the A horizon consists of the topsoil. Okay, so this is typically mostly sand and some clay. So this is rich in humus, okay, which is the O horizon, and it is leached soil deficient in humus and minerals, okay? So consists of topsoil. That's the big piece we need to know. Next is the B horizon. So this is the subsoil. So think underneath. So this is reddish brown in color, and it's made mostly of clay, and it is very rich in minerals and nutrients. Last is the C horizon, which is the deepest layer. Okay, so we're working from top to bottom, and this consists of broken and solid, okay, unweathered bedrock. So if it's unweathered, what does that mean? Because we talked about weathering, and weathering does what? It breaks it down. So these are the opposite if they're unweathered, so they're not broken down, okay? So this is what this looks like. So you've got your A, B, C. So your topsoil, subsoil, and then the rock underneath. So we talked about weather and climate determines the type of soil that is found in a specific area. So in a humid tropical climate, there is a very thick O horizon, which we saw at the very top, okay? And this is very acidic soil. Next is the desert, and in a desert climate, okay, there's thin soil that consists mostly of a regolith, okay? So humid tropical, thick O horizon at the top, acidic soil, desert climates thin, consisting mostly of our regolith. So in a temperate climate, we've got petal fir, which is found in areas east of the Mississippi River. And these typically receive more than 65 centimeters of rain a year, mostly clay, quartz, and iron. So this is acidic. Then there's the peduncle, and this is found in areas west of the Mississippi River, in areas that receive less than 65 centimeters of rain a year. So these contain calcium, they're less acidic, and typically very fertile, okay? So this just gives you an idea on the map. So east versus west of the Mississippi. So we're east over here, west over here. What? All right, so soil on a mountain or hill is usually thin and of poor quality. And this is because rainwater runs down and washes it away. So think of a hill. So the rain comes down and it will wash everything away. And then lastly, North Carolina soil. So where we live, North Carolina's main soil type is sisal. And this is found above granitic rock. And it has a very thick red subsoil. Okay, so when we're talking about the soil type, we're thinking closer to the top. Okay, and then the subsoil found right underneath is a thick red subsoil.